Spice Math. That's right. We add it up, multiply it, man. Spice Math. Okay. A couple things we're gonna learn today. Spice Math. All right. Take some time, educate yourself. Spice Math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Doughton.
Hi, I'm Aaron Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Doughton.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math. Just math.
Hello once again, welcome back to Spice Math. And today we'll be looking at rounding off and a few of the decimals that we spoke about in a previous lesson. This lesson is geared towards students of the Form 3, Form 4 and Form 5 levels. And for those of you who need a review as you prepare for CSEC coming up in the next couple of months. At the end of the lesson today, you will be able to differentiate between decimal places and significant figures or significant digits. You'll be able to round a number or round off a number to a specific amount of decimal places or a specific amount of significant figures. First, let's do a definition of what rounding off is. Now, rounding is a way of approximating numbers so that they can be realistically easier to represent or to be reported. For example, if we had this number as a measurement for meters, it would be a precise measurement mathematically. But realistically, if you were to stand close to a meter rule, it would be almost impossible for you or I, with the naked eye that is, to represent 2.12759 on the meter rule. It would be more realistic then to convert that number to something that we can see or we can maybe touch, hence the word realistic. And so we can round it off to a certain number of decimal places or a certain number of significant figures, which we're going to look at a little later on. What is decimal place? Once again, another definition. The decimal place is really the place or the position of a digit to the right of the decimal point. And if we go back to the example on the board, you'd notice that if we're going to count decimal places here, we'd have to count from the decimal point and move to the right. So in this number, there are 1, 2, 3, 4, 5 decimal places. We could then go on to round it off to maybe 2 places of decimal to be a little more realistic. What would happen then? What is the process of rounding off? How do we make that approximation so that it would fit within realistic understanding of mathematics and numbers? When you're rounding off a number, you can either round up or you can round down. But before that is done, we have to find what is the target digit. So for example, in a question, we may be asked to round off to 3 decimal places. It means, therefore, that the third decimal place from the decimal point going to the right will be our target digit. So in this case, if you look at the number on the board, you'd notice that the target digit, if we're looking for 3 places of decimal, would be the 7. Starting from the decimal point, moving to the right, 1, 2, 3. So our target digit is the 7. How then does the process proceed? If we want to round up this number to 3 decimal places, the numbers on the right automatically become 0. So, the result is 2.12700 in place of the 5 and the 9. However, we ought to also consider what those numbers were before we turn them into 0. And that's where the challenge of rounding off comes. Because if the number immediately after the target digit is less than 5, we round down or we keep the target as it is. But if the number immediately after the target digit is a 5 or a number greater than 5, we add 1 to the target digit. So in this case, the target digit was 7 because we wanted 3 decimal places. The number after it, which was turned into a 0, was a 5, so we need to add 1 to the target digit. And so this is our answer. 2.128 is rounded off to 3 decimal places from the number 2.12759. So what really is rounding off? 1, it is identifying your target. And 2, it is deciding whether you're going to round up or you're going to round down. Let's move on. Or let's look at an example. Another example. Let's suppose we had this number. And you were asked to round it off to 1 decimal place. That would imply that our target digit would be the first decimal place, in this case, 0. Then we need to look at the numbers that come after the 0. Target is the 0. Because we were asked to do it to 1 decimal place. So all the numbers after the 0 will become zeros. So our answer would begin 423.0. Then we look at the number that came immediately after the 0 in the original number to determine whether we're going to round up or down. The number after the 0 is 1. Remember the rule? If the number after the target is less than 5, then we round down or we keep the number that's in the target. If the number after the target is a 5 or greater, 5 or 6 or 7 or 8 or 9, then we round up. That is, we add 1 to the target digit. In this case, the number after the target is 1. So which means we're going to round down or keep the number on the target as it is. Hence, 423.0172 is equal to 423.0 to 1 decimal place. Answer. You will get an activity coming up that would give you the opportunity to practice this. So let's move on to the next concept. What is a significant digit? Now, in a previous lesson, we mentioned that we're working with base 10 or the decimal system. And in that system, we have a total of 10 digits, starting with 0. Significant digits are all the non-zero digits in the decimal system. So, from the 1 to the 9, all significant, always significant. The only challenge is the 0. From a previous lesson, you would have learned from Mr. Dotting that 0 is a whole number and is a member of the set of whole numbers. 0 is not normally significant, except there are 2 exceptions to the rule. 0 can only be significant, 1, if it is enclosed between 2 other natural significant digits or significant figures. So, for example, this number, 3,104, the 3 is significant, naturally, so is the 1 and the 4. And the 0 is now significant here simply because it fits the exception to the rule. It is enclosed within 2 other significant digits, 1 and 4. So this number is, or rather contains, 5 significant digits. Next example. Let's suppose we have this number. $2,070. The 0 between the 2 and the 7 we know is significant. However, we're faced with another case. How many significant digits does this number have? 2070? 1, 2 are naturally significant. The 0 between the 2 and the 7 is also significant because it fits between 2 others. But the 0 after the 7 is not considered significant except the number has a decimal point. So this number, 2070, has 3 significant figures. But if we had written it as 2070 with a decimal point, it will now contain 4 significant figures. That is, the 0 enclosed between the 2 and the 7, and the 0 immediately before the decimal point. 4 significant figures. Now the second point concerning significant figures is when it follows, that is, the number 0 follows a significant figure which also follows the decimal point. Let's look at an example. $48.000 would contain 5 significant figures simply because the zeros follow the decimal place and they also follow a significant figure. The same thing would happen if we had had this example. $3.2700 would contain 1, 2, 3, 4, 5 significant figures because the zeros on the right-hand side of the number follow a significant figure which follows the decimal point. In today's lesson, we looked at how to round off with a few principles, and we looked at the difference between decimal place, which involved the number of places to the right of the decimal point, and significant figures with the 0 exception. We're going to look at some activities that you can relate to. Activity number 1. State the number of decimal places in the following. A, 22.0. B, 0.00049. C, 1 quadrillion. D, 4.1603. E, 588. F, 7.5261394. Let's look at activity number 2. State the number of significant digits in the following. Look out for the zero exception. A, 3,970. B, 20.00. C, 920,600. D, 4,008. E, 30,000. And F, 1,008,020. The other two activities, activity 4 and 5, will be given to you as an assignment for you to practice. Thank you very much, and see you again next time.
just